Welcome back to calculus class. Today's topic is finding the area between two curves. So this information in the box is from our note card for today. The area of a region of between two curves. If f and g are continuous on the interval from a to b and f of x is greater than or equal to g of x. So f of x is like your upper function and g of x is your lower function, or they could come together and be equal. For all x values in the interval from a to b, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is area equals the integral from our lower x value a to our upper x value b of f of x, the upper function, the bigger function, minus g of x dx. Okay? So let's start with problem 1. It says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So the first thing we want to do is sketch the graphs of the region. We don't always have to sketch a graph, but we're going to on this first one to kind of get a visual for what we're doing. So the x squared plus 2 graph is a parabola with a vertex instead of at the origin moved up 2, so at 0, 2. And then it's going to be just the basic parabola, out 1, up 1, and then it goes out 2, up 4, which won't even quite fit here, so it'll just curve upwards and never reach this vertical line on the portion of the graph that we have shown. Okay, now we also have the graph y equals negative x, so that's the same as the linear parent function, except for the slope, instead of being positive 1, is negative 1. So it's going to go basically through the diagonals of each unit square here. So there's our line y equals negative x. And then we have vertical lines at x equals 0, which is your y-axis, and x equals 1 right here. So we're finding the area of this region that I am coloring in with a yellow highlighter. It looks a little bit like a trapezoid, but this edge is curved. So we are going to find the exact area, not an approximation, but the exact area for this region. So the area will equal the integral from the leftmost x value, which is 0 on this shaded region, to the rightmost x value, which is 1, and they gave us these numbers in the problem. And then we're going to have f of x, which is our upper function. Notice the parabola is above the line, so the parabola is f of x, so it'll go first. X squared plus 2 minus the lower function, y equals negative x, so that's the negative x. Okay? Whatever y equals, we put that part, f of x minus g of x. And then our dx. So let's just clean this up a little. We don't want all this minus negative stuff. And I kind of like it in order of descending powers of x. So x squared plus x plus 2 dx. So we're going to integrate this from 0 to 1. So let's first integrate. The integral of x squared is 1/3 x cubed, power rule backwards, plus the integral of x is 1/2 x squared, and the integral of 2 is 2x, and this will be evaluated from 0 to 1, and those are super nice, easy numbers to sub in. So we'll go 1/3 of 1 cubed plus 1/2 of 1 squared plus 2 times 1 minus 1/3 of 0 cubed, plus 1/2 of 0 squared plus 2 times 0. So all these 0 things are going to multiply by 0 and go to 0. So we'll have 1/3 plus 1/2 plus 2 minus 0. And so we just need to do some arithmetic to get the answer. We could get this all in terms of sixths. So this would be 2/6 plus 3/6 plus 12/6. So 12 and 5 makes 17/6. So that is the area of this region that I've highlighted on the graph. Okay, so now that you understand the basic process, we'll look at a few other examples of how this can all work. Number 2, find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. So this one is very similar. We'll go ahead and make the graph. So we still have a vertical shift of 2, so our vertex will be at 2, but this time our graph opens down. So out 1, down 1, because of the negative x squared, and then out 2, down 1, 2, 3, 4. And 3 would be down 9, 1, 2, 3, 4, 5, 6, 7. We don't quite have enough room to go to that one. So we've got the downward opening parabola. And then g of x is equal to x. That is your linear parent function. So it'll pass through the origin and have a slope of 1, rise 1, run 1. So we're looking for the area of the region bounded between these two graphs. Now, on the last problem, they told us the x values to work between. This one, it does not give us that in the problem. So we're just going to look for the left intersection point and the right intersection point and work from there to there. So it's easy to see this on the graph. They intersect when x is -2 and again when x is 1. But if you weren't going to make a graph, which is not necessarily required to do these problems, you could find the intersection point by setting the two equations equal to each other and then solving for x. So that's how you would do that. Okay, so we've got the area is equal to the leftmost x value for our region, which is -2, to the rightmost x value for our region, which is 1. And then upper function, which is our parabola, 2 minus x squared, minus the lower function, which is the linear function x, dx. And so now we're going to integrate by using the power rule backwards. So the area will equal 2x minus 1/3 x cubed minus 1/2 x squared. And that will be evaluated from -2 to 1. So we will substitute in the upper limit of integration, 1, for each x value, and then subtract what we get when we plug in the lower limit of integration, -2, for each x value. And now we'll do some arithmetic. 2 minus 1/3 minus 1/2 minus, in parentheses, -4. This is -8/3. No, +8/3, because this is -1/3 times -2 cubed. And then we're going to have 4 times -1/2, which is -2. Okay, so probably going to want to get this in terms of 6 also. So we'll have 2 minus 2, 6, minus 3, 6, plus 4, minus 16, 6, plus 2. Okay, so 4, 5, 6, 7, 8, we'll have 8. And then negative 16 and negative 5 makes negative 21, 6, which, let's see, 6 times 3 is 18, 6 times 4 is 24, so this is 8 minus 3.5, and then that is going to equal 4.5. So the area of this shaded region is 4.5 square units. Pretty cool. All right, this next one is going to be a bit of a doozy, but we can do it. It says find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. So we don't need to make a graph of these two functions in order to find out how to set up this integral, where they intersect and which one's above the other. What we are going to do is do this by hand without the use of a calculator and without the use of making a graph. So the first thing we want to do is find the points of intersection, and we'll do that by taking our f of x and our g of x function, setting them equal to each other and solving for x. So we'll have 3, here we go, 3x cubed minus x squared minus 10x equals negative x squared plus 2x. So we'll start by getting this all set equal to 0. So I'll add x squared to both sides, which is kind of nice because these x squareds actually add up to 0 on both sides. And I'm going to subtract 2x from both sides, so I'll have 3x cubed minus 12x equals 0. And I'm going to factor this, so the greatest common factor would be 3x. And if I take out 3x, I'll be left with x squared minus 4. And x squared minus 4 is a difference of squares, so it factors as x plus 2, x minus 2. And if I set these equal to 0, then I get x equals 0, x equals negative 2, and x equals 2. So I have 3 places where these two graphs intersect each other. How is that possible? Well, there's a couple of different ways that could happen. One could come down and bounce and hit the other one, and there could be 2 little regions, 2 little blobs we're finding the area of, or it could be that the one was on top and then they changed places and it's on bottom. But basically there are going to be 2 separate regions that we're finding the area between. So we're going to have to set this up as 2 separate integrals. We're going to have one integral going from the smallest x value, which is negative 2, to the middle x value, which is 0. And the other one is going to go from the middle x value of 0 up to the largest x value of 2. But we do need to figure out which one is above the other one at each of these points. So I need to pick a value between negative 2 and 0, and a number between 0 and 2, and substitute them into both equations to see which one is higher than the other. So whichever one has the greater y value when I sub that number in. So let's do f of negative 1 and scoot this down a little, g of negative 1, and see what those come out to. So if I do f of -1, I have 3 times -1 cubed minus -1 squared minus 10 times -1. So that's -3 minus 1, which makes -4, plus 10, which is equal to 6. Now let's plug the -1 into the g of x and see what we get. -1 squared plus 2 times -1 is -1 minus 2, which is -3. So the f function has a y value of 6 when the g function has a y value of -3. So the f function is above the g function between the x values of -2 and 1. So my first integral will be the integral from -2 to 0 of the f of x function, 3x cubed minus x squared minus 10x dx. And then we're going to add that to the integral from 0 to 2 of the other region, which we also need to find out which function is higher. It's possible that they change places. It's also possible that they meet and then kind of bounce apart again, and the same one that was above stays above. So we just don't know until we sub in a value and see which one comes out on top. So we're going to substitute in 1, f of 1 and g of 1, and see what that comes out to. So 3 times 1 cubed minus 1 squared minus 10 times 1, and -1 squared plus 2 times 1. So this is 3, take 1 away is 2. 2 minus 10 is -8. And then here we have -1 plus 2, which is 1. So the g function is above, so they did trade places. So for this integral, I'll have -x squared plus 2x minus, oh my, did I not subtract in the other one? Okay, I just wrote the f of x function and stopped. That's just beautiful. Not really. So -2 to 0, 3x cubed minus x squared minus 10x minus -x squared plus 2x dx. And then we will add to that the integral from 0 to 2 of the g function, -x squared plus 2x, minus, in parentheses, our f of x function, 3x cubed minus x squared minus 10x dx. So for this first one, I should have had the subtraction of the g of x function. So we'll just mark that out. Okay, now, this is a lot of work to do by hand integrating, but the first step is going to be to distribute these negatives and combine like terms. So let's see what that gives us. 3x cubed is the only cubic term. Now we have -x squared minus -x squared, which is the same thing as -x squared plus x squared. So our x squared terms will go away. And then I have -10x minus 2x. So that's going to give me -12x, -12x dx. So that's a lot less than what it was. Plus the integral from 0 to 2 of, we just have the cubic term, -3x cubed, because this negative distributes to all three terms. And then -x squared plus x squared, those are opposite signs, so they add to 0. And then 2x minus -10x gives us +12x dx. All right, now we are going to integrate by using the power rule backwards. So if I add 1 to my power here, it'll be x to the 4th. Multiply by the reciprocal of my new power, that's 1/4, which multiplies by the 3 here. So 3/4 x to the 4th. Now add 1 to my power here, that'll be x squared. Multiply by the reciprocal of that new power, 1/2. 1/2 multiplies by the -12, which gives us -6. And that's going to be evaluated from -2 to 0. Plus the other one, which is going to be -3/4 x to the 4th and positive 6x squared. You'll notice these are the exact same terms, just opposite signs. And this is evaluated from 0 to 2. So now we're going to sub in the upper limits and subtract what we get when we sub in the lower limits of integration. So we'll have 3/4 of 0 to the 4th minus 6 times 0 squared minus 3/4 of -2 to the 4th minus 6 times -2 squared plus -3/4 of 2 to the 4th plus 6 times 2 squared minus -3/4 times 0 to the 4th plus 6 times 0 squared. Okay, so this is all 0, 0 and 0. And now we're going to have -2 to the 4th, which is 16, times 3/4. So 16 divided by 4 is 4, times 3 gives us 12. So we'll have the negative out in front, 12 inside. -2 squared is 4. 4 times -6 is -24. Plus 2 to the 4th is 16, times -3/4 is -12. And then 4 times 6 is 24. And then this is minus all 0 inside of the brackets here. So 12 minus 24 is -12. But then times the -1 in front gives us positive 12 plus 24 and -12 is another positive 12. So the area is 24. All right, that's it. Now, it's very likely that you would be given a problem like this on a no calculator problem. So I strongly suggest that you do them without a calculator unless you are told explicitly to use one. But after you've gotten it done, you can always look in your calculator. Let's see, go to y equals. Let's put in these two functions. 3x to the 3rd minus x squared minus 10x, and then the other one is -x squared plus 2x. So I'm going to graph these. There's the cubic, and there's the quadratic. So what we found was the area of this blob and this blob, these regions in between the graphs. And we certainly could have done this in the calculator, but we'll look at the next problem for that because the next problem is a calculator problem. So the next problem says, let R be the shaded region in the first quadrant enclosed by the graphs of y equals e to the -x squared power, which they have that graph shown right here. Y equals 1 minus the cosine of x, which is this one right here, and the y-axis as shown in the figure. Find the area of the region R, and this is a calculator problem, okay? So the area is equal to the integral from the leftmost x value, which is, since we're going from the y-axis, going to be 0, to the rightmost x value. And it looks like it's close to 1, but we don't actually know this intersection point, and we do need to know that intersection point in order to figure out what the upper limit of integration is. So I'm going to go into y equals in my calculator and type in e to the power of negative x squared and 1 minus the cosine of x. And I want to make my window match what they have here on the graph shown. So I'm going to go window, x min 0, x max 1.5, that's a very small region, and then they're counting by 0.5s along the x-axis. The y min is also 0, the y max is also 1.5, and they are also counting by 0.5s here as well. So now I'm going to hit graph, and hopefully this graph looks a lot like the one you see on the paper. It's nice when they give you a graph and it's on the calculator portion because it makes it really easy to know how to set everything up. So we need to know this intersection point. So we're going to use the calculator to find it. We're going to hit second and the trace button for the calculate menu. And then we're going to choose number 5, which is intersect for the intersection. And it says first curve question mark, and it's asking me which is the first one you want me to look at. And the reason it does this is because you might have up to like 10 graphs in here at the same time, and it can only find intersections between 2 at a time. It tells you at the top which equation it's on. So yeah, that's good. y1, e to the x1. So we're going to hit enter. Then it jumps down to y2. It's on the cosine one now, and it's flashing there. Second curve question mark. Yes, looks good. So we're going to press enter again. Then it says guess question mark. We just press enter the third time here. And it tells me that the intersection is 0.941-94408 for x, and then the y value. We need the x coordinate because we're doing leftmost x to rightmost x, okay? Now, this is not the final answer to the problem. And you hopefully will remember that I've told you this year that one of the most common errors that they find on the AP exam is called premature rounding. Rounding off an answer and then using that rounded off answer to find another answer. You're not allowed to do that on the AP exam. You have to use all the decimals that are given. So I'm going to write them down. X equals 0.9419448. And over here on my integral, I could write them all out here, or I can write it down as 0.942, but I cannot enter it in my calculator as 0.942. I have to use all the digits in the calculator, okay? So I'm going to put in the upper function, which is the e to the negative x squared, minus the lower function. This lower one needs to be in parentheses because the negative needs to distribute to both the 1 and to the negative cosine of x dx, okay? So when I go to my calculator, I'm going to go back to my home screen, and I'm going to press alpha window, option 4, which is function integration, and my lower limit is 0, and guess what I'm going to type for my upper limit? Not 0.942, that would definitely be wrong. I could type in all these digits, or there's this neat feature of your calculator that whatever the last x equals value is that you searched for by using the calculate menu is stored as x, as a constant, and you can actually enter that and it'll pull all those decimal places for you. So that's a neat, sneaky trick for you to use, shortcut, to save you some time. So now I'm going to type in e to the negative x squared minus parentheses 1 minus cosine of x, and of course it'd be fine to distribute that x and then, distribute that negative and then not have the extra parentheses, dx. And you might be wondering, well, isn't it going to use that same x value here? No, this is a function and it's considering it differently than the constant, so you're good. And now here it gives me the answer. The area is equal to, and since this is the final answer, we do round it to 3 decimal places, unless explicitly told to do otherwise. 0.591 is the area that we're looking for on this problem. Okay? That's it. That one is a done deal. All right. So now we have 3 more to do. We will, let's see, I want to do, why don't you pause the video and try number 5 on your own. And I'm going to let it be your choice, whether you use a calculator or not. But on number 6 down here, when we get to that, we're going to do this one with no calculator. And on number 7, we're going to do with a calculator, just so that we get a little bit of practice with each of these methods. But I want you to try number 5 on your own, and you get to choose whether you use a calculator or not. So hopefully you've paused the video and come back and ready to see if you got your answer right. I'll just go ahead and tell you right now so you know whether you got it right or not. The answer was A, 1/4. Did you get it right? If so, you're in good shape. So number 5 says the area of the region, this should have been in the first quadrant, that is enclosed by the graphs of y equals x cubed plus 8 and y equals x plus 8 is. So the first thing that we have to do is set these equal to each other. X cubed plus 8 equals x plus 8 to find their intersections. So we'll subtract 8 from both sides, and now it's just x cubed equals x. And if we subtract x from both sides, we can go x cubed minus x equals 0 and factor the greatest common factor, x, out. So that's x squared minus 1 times x. And then x would equal 0, or x squared minus 1, of course, is a difference of squares, x plus 1 times x minus 1. So x would equal positive 1, or x would equal negative 1. So we've got 3 x values where these graphs intersect. But it says in the first quadrant, it's underlined, it was important. So we're not going to use the x equals negative 1. We're only going to integrate from 0 to 1. We just want that portion. And we need to do upper function minus lower function. So which one is on top? Well, we're going to have to sub in a number between 0 and 1 to both functions and see what comes out as the bigger value. So let's say we sub in a half. 1/2 cubed plus 8 is 8 plus 1/8, 8 and 1/8. And then 1/2 plus 8 is 8 1/2. So which is the bigger value? 8 1/2 is bigger than 8 1/8. So the linear function is above the cubic function. So we're going to go x plus 8 minus the quantity x cubed plus 8 dx. And that negative distributes. So we'll have a negative x cubed plus x, and then we have 8 minus 8. So those add to 0. So that's all we have to integrate right there. So if we were to do this one by hand, we would have power rule backwards, add 1 to the power and get x to the 4th, multiply by the reciprocal of that new power, and it multiplies with the negative 1, so it'll be negative 1/4 here, plus 1/2 x squared, and this is evaluated from 0 to 1. So negative 1/4 times 1 to the 4th power plus 1/2 times 1 squared minus negative 1/4 times 0 to the 4th plus 1/2 times 0 squared. So negative 1/4 plus 1/2 minus 0, that is 1/4. So there we go. That's the answer. All right. On number 6, we're going to do this one without a calculator. The area of the region between the graphs of y equals 4x cubed plus 2 and the x-axis from x equals 1 to x equals 2. Well, what's the equation for the x-axis? Y equals 0. So it's going to be the cubic minus 0. So basically, we're just integrating the cubic function. In fact, we did work some problems like this when we were doing definite integrals and the fundamental theorem of calculus earlier this year. Before we even learned how to find the area between two curves, we learned how to find the area between a function and the x-axis. So this one is actually kind of a review. So the area is equal to the integral from 1 to 2 of 4x cubed plus 2 dx, because the second function is just minus 0, which you don't really have to write. So we do power rule backwards. X to the 4th. 1/4 multiplies by the 4 that's already here, so that's a coefficient of 1. And then plus 2x, and this is evaluated from 1 to 2. So we're going to go 2 to the 4th plus 2 times 2 minus, parentheses, 1 to the 4th plus 2 times 1. So this is 16 plus 4 minus 2 plus 1 is 3. So 4 minus 3 is 1. 16 plus 1 equals 17. So the answer is D, 17. All right, this last one we're going to do with the calculator. And it says the area of the region enclosed by the graphs of y equals x and y equals x squared minus 3x plus 3 is which of the following? So I am going to go into y equals, and I'm going to type both of these functions in. Y equals x and x squared minus 3x plus 3, and graph them. So there's the linear, and there's the parabola. So I want the region enclosed by these graphs. So that's going to be this little part of the parabola that's under the line, and the line caps it off on top. So I can see the line is above, so my integral will have x minus, in parentheses, x squared minus 3x plus 3, because the linear function is the higher function on this region. And then I need to know the intersection points. So I'm going to use the calculator to find those, since this is a calculator problem. But I might want to go in a little closer with my window so that I'm not looking at quite so much of this extra stuff I don't need. So let's see if this helps. There's the line, there's the parabola. There we go. This is the region we're trying to find the area of. So I'm going to go second, and then the trace button for calculate. Intersection is number 5. First curve, I want to arrow close to the first intersection point because it's only going to find one at a time. First curve, enter. Second curve, enter. Guess, enter. And it says it's at 1, 1. So the lower x is going to be 1. Now I'm going to go second, and the trace button for the calculate menu. Choose number 5 for intersect again. And I'm going to right arrow over here to this intersection point. Press enter. Second curve, enter. Guess, enter. And this one is 3. So now I will be able to integrate from 1 to 3. So I'm going to go back to my home screen, and I'm going to go alpha window number 4 for function integration. The lower limit is 1, the upper limit is 3. Now I could type this in, or because I've already got them typed in, I can go alpha trace y1, because I put the y equals x in y1, minus alpha trace y2, because I put that quadratic in y2, dx. So that gives me 1.3 repeating, which is 1 1/3. So that, well, which would be the same thing as 4/3, wouldn't it? Because 3/3 is 1. So 4/3 is the answer. Okay. Now I wanted to point out one more thing before I let you go, If you were to do these in the opposite order, so if I was to go alpha window, function integration from 1 to 3 of y2, so alpha trace y2 minus alpha trace y1, so they're backwards. So my upper function is written second and my lower function is written first. You are going to get the same answer as you did, except for opposite sign. So it's going to be negative 1/3, which 1 1/3, which is wrong because the area is not negative, it's positive. But just so you know, if you end up getting a negative answer from one of your areas, that is a strong indication that you've reversed the functions. You've got them in the wrong order. The lower one is probably the one that you wrote first instead of second where it belongs. So just wanted to make that note for you. All right, I hope that this lesson goes really well for you. Try to do as much of it without a calculator as you can, unless you're told to use a calculator. So good luck, have a wonderful day. Let me know if you need help, and bye for now.